Welcome to this lesson then, and we're going to focus on the actual sketching of graphs and the inverse functions themselves. So in the previous two lessons, we've had a look at domain and range of a function and how to find the inverse function itself, including the inverse function domain and range. And in this lesson and video, we're going to focus on how we can put those functions into a graph. And first of all, a simple tip really is to reflect the original graph f in the line y equals x. So it's just knowing your functions and how to graph them effectively. So in this example then, I've got a function x squared plus 1. It's got a domain of 0 to infinity. So only values from 0 to infinity can go into the x here as an input. The output then will be from 0 squared plus 1 up to infinity squared plus 1. So the range is going to be from 1 to infinity on this function. And if I want to find the inverse function of x squared plus 1, remember I let f(x) equal y and then swap the sides over in order to rearrange the function. So x squared is equal to y minus 1 by taking 1 off both sides. And then to find x, we need to square root y minus 1. And we need to consider the positive and negative roots here. Now, if we have a think about this, then the inverse function of x, the domain of this function must be 1 to infinity, because the range of the original function f is from 1 to infinity. And remember, that becomes the domain of the inverse function. And the range of the inverse function is from 0 to infinity. It's the domain of the original function. So I know that this range here is positive. I'm going to take positive values. So I'm only going to take the positive root here. So the inverse function is the positive root. And we substitute y back with x, or x minus 1. Now we come to the graph then. So first of all, I'm going to focus on the original graph. And from 0 to infinity domains, 0 squared plus 1 is 1. So I know this graph is going to start here at 1. Okay, and I know what x squared is like. For example, 1 squared plus 1 is 2. So at 1, when the input is here 1, it's going to be 2. So I know that it's going to have a parabola and it's going to go off to infinity quite steeply. So this is my original function, f of x. Now my inverse function here, okay, can be drawn. We know that the domain is from 1 to infinity, and we know that when it's the root of 1 minus x, that's going to be 0. Okay, so referring back to the original, referring back here to the function, okay, over here, okay, root of x minus 1, and drawing the inverse function looks like this. That's the shape of a root graph. Okay, and as you can see, the distance between all the points is equal distance away from this line, y equals x, which is our mirror line, which is the important line for drawing an inverse function. So this is our inverse function of x and the graph of it, okay, in the shape of a root graph. So what I want you to do is make some notes on that by pausing the video, all right, and then what I would like you to do is I would like you to have a go at this main task. Again, pause the video and have a go at drawing these 3 graphs with their inverse functions as well. All right, and when you're ready, press play and we'll go over them. So pause the video now. Okay, welcome back then. So quickly go over some of these graphs. So we've got here a linear graph, haven't we? So let's come to our graph here, and we need the line y equals x in. Now, drawing this as steady as I can. Okay, as the line y equals x ready for drawing my functions. Now, it says for all values of x. So for f of x, the domain is all values of x, so from minus infinity to infinity. As it's a linear function, yeah, when you substitute in minus infinity here, we're going to get 3 lots of minus infinity plus 2. So just minus infinity and the same the other way. So the range is from minus infinity to infinity. We know how to draw this graph already. So let me just change my color pen a moment. So we know that it crosses the y-axis. There's a y-intercept at 2. And this graph here has got a gradient of 3. And this graph here, the line here has got a gradient of 1. So I know it's going to be steeper. So I'm going to draw and steadily. There we go. Straight line graph with a steeper gradient. And this is the graph 3x plus 2. So the original function of x. Now, your inverse function is just to rearrange 3x plus 2. So hopefully you've come up with x minus 2 over 3. So the gradient of this function here is 1/3. And again, the domain and range look, even if we swap these over, still minus infinity to infinity for both. Just change the color of pen. But I know, I'm going to use that blue one there. So I use that for the line y equals x. Let's use a purple one. So I know that this isn't going to have a steep gradient. But I do know when x is 2, if I put 2 in here, 2 take away 2 is 0. I know it's going to cross through here at 2. So that would correspond with this crossing through there to the original graph. And if I draw now, my straight line has got to go through here. And it's got to go through the 2 straight line. And again, it will go off to infinity, but much slower. And as you could see, the line y equals x acts as a reflection line for the 2 graphs. So here is my inverse function of x as well. And it's important to note on the axes any points of intersection if we know them. Okay, question 2 then, we've got the graph x squared. We know that's a parabola shape. We know the domain is 0 to infinity, so 0 squared is 0 all the way up to infinity squared, which is infinity. So we know that's got a range. So the domain and range of my inverse function is also going to be 0 to infinity. Now, on here, let me just draw in again, if I can, my y equals x line. Now, I don't need to extend it to this part of the graph because we know we're only going to be dealing with the positive side. So there's y equals x. And we know that, let me just get a different color pen, the x squared graph, we know the shape of it, and we know here at 1 squared is 1. But for this part of the graph, it goes under and up through. So we know we've got a curved graph there. Okay. So our inverse function for the root is also going to start at 0 because, just to find out, the inverse function is the root of x, and it's the positive root because both domain and range are 0 to infinity on my inverse function, so it has to be positive. And then to draw this, it's just a reflection in the line y equals x. So again, nice and steady curve, and it goes off this way. So this is my inverse function graph, and this here is my original function of x squared for 0 to infinity. Okay, e to the x plus 1. So again, very quickly, I'll just draw in my y equals x. Yeah, y equals x. Okay. Now, I know that all values here, but if I put in these negatives in here, just goes to 0. But I know that e to the power 0 is 1. So e to the 0 power 0 plus 1 is 2. So I know it's going to go through there at 2. It's going to have an asymptote line there of 1. Okay, so just to draw my original graph of e to the x plus 1. Steadier. And that's the shape of the exponential function. So when I come to do the inverse function, it'll be e to the x plus 1 equals y, just rearranging that. So take one off both sides, and then you'll need to take the natural log to both sides. So x will be the natural log of y minus 1. So the inverse function is the log of x minus 1. Okay, and domain, so the range of this one here, the range is from 1, as we can see, because it never goes below or never hits 1. So it's from 1 to infinity. So I know that and that's the range there of the original function. So I know the domain of the inverse function goes from 1 to infinity. And I know that the range is the domain of the original function, so minus infinity to infinity. Okay, so I know that I'm also going to have here, let me just change my color pen again. Okay, so 1 here. It's going to cross through here at 2. 2 minus 1 is 1, the log of 1 is 0. So yeah. Yeah. Okay, so just put this back in here. 1, we know it goes from here. And then this, our inverse function, here, it goes up and it goes this way here and it crosses at 2. So there's my inverse function of x. Here is my original function of x. And there was my line y equals x. And as you can see, they're perfectly symmetrical around y equals x. Okay, checking question, and again, pause the video, and when you're ready, have a go. Okay, so do that now. Okay, welcome back then. First of all, then we're going to find the expression for f minus 1. So here, look, the domain is greater than or equal to 0. So hence the square bracket. So 0 to infinity. We're squaring a number. So when it's 0, 0 squared is 0. 3 times 0, 0 plus 4. Okay, and then when you do that, or when you put values in between 0 and infinity, you're going to square them, multiply them by 3 and add 4. They're going to go off to infinity. So the range is going to be from 4 to infinity. Now that's important for the range and domain of f minus 1, the inverse function. So if we start by saying that 3x squared plus 4 is equal to y, start rearranging. So take 4 off both sides first of all, then divide through by the 3. Okay, so you know y minus 4 all over 3. And then we need to square root it. So be the square root, y minus 4 all divided by 3. Need to decide whether it's positive or negative. Well, it's going to be positive because the domain of the inverse function is going to be 4 to infinity, and the range is going to be 0 to infinity. Okay, so we know the range is going to be positive, so the inverse function is going to be the positive root of x minus 4 over 3. Now, in terms of your graph, again, you want your line y equals x in. So your original graph then, when it's 0, it starts at 4. It goes off to infinity. And your inverse graph, remember, the domain starts at 4. So it starts here at 4. And again, it's the root graph. So again, it goes off to infinity, but far slower. Okay, and that's your line y equals x. And that's how we do the inverse function and graphs. Thank you for listening.